For this first question, we have a quadruple expansion of x plus y. Let's rewrite this as x plus y squared, all squared. First, we expand x plus y squared, which is x squared plus xy plus y squared, which simplifies to x squared plus 2xy plus y squared. Multiplying this by itself gives x to the power of 4 plus 2x cubed y plus x squared y squared plus 2x cubed y plus 4x squared y squared plus 2x y cubed plus x squared y squared plus 2x y cubed plus y to the power of 4. Yikes! Simplifying all of that gives this. I am not going to try say all of that again. Now we have a quadratic-looking expression we need to factorize. Let's start by making it a quadratic by replacing x squared with the letter a. Now we need to factorize this quadratic by multiplying the coefficient of x squared by the last term to get 36. We are looking for numbers which times to get 36 and add to get negative 13. These numbers are 4 and 9, so let's put it into two brackets with 4a. Because we multiplied by 4 at the beginning, we need to divide one of the brackets by 4, so let's divide the first one. Putting the x squared back wherever there is an a gives x squared minus 1 and 4x squared minus 9. These are the difference of two squares. We can factorize them both. The first into x plus 1 and x minus 1, and the second into 2x plus 3 and 2x minus 3, remembering to square root the 4. This last challenge question from the mixed exercise wants us to simplify these surds. When expanding out these brackets we get a plus root ab minus b, remembering that a root multiplied by itself gives the thing under the square root sign. This simplifies down to a minus b. This next part of the question we have a sum of fractions with surds on the denominator. When you see a surd on the denominator of a fraction, you should always think about rationalizing. We do this by multiplying each fraction by the first surd minus the second. We know this gets rid of the surd from the proof we did for part A. We can see the denominator is always negative 1, so we can simplify these fractions by writing it like this. Now we can do a bit of cancelling with the middle terms. We can see that each of the middle surds has a negative counterpart, which means we are left with just minus root 1 plus root 25. Which simplifies down to minus 1 plus 5, which is 4 as required.